All right, welcome back again. We left off from this slide. All right, just real quick recap. How do hurricanes form? Remember, hurricanes need three conditions to form: that low air pressure, that warm temperature, and that moist ocean air, right? All that moisture, right? So, moving on from this, we're going to talk really quickly about El Nino, okay? So El Nino and La Nina. What are El Nino and La Nina? I wanted to really hit on this really quickly before we go more into the detail of hurricanes. But when you think of El Nino, I want you to think of the warming water in the Pacific Ocean. La Nina would be the cooling of water in the Pacific Ocean, okay? So looking here, El Nino weather. You have rain and flooding along the Pacific coast. Warm water disrupts food chain of fish, birds, and sea mammals. Tornadoes and thunderstorms in southern United States. Fewer than normal hurricanes in the Atlantic. Then La Nina weather, this is when you have the cooling of water, right? Cooling of water. You have snow and rain on the West Coast, unusually cold weather in Alaska, unusually warm weather in the rest of the United States. You have drought. Okay, this can happen in the southwest, and higher than normal number of hurricanes in the Atlantic. So when we talk about hurricanes, or when meteorologists and different systems talk about hurricanes, is always they're always wondering about what's going on with either El Nino or La Nina. So I'm going to visit this here just to kind of go over hurricanes a bit more. Let's see, click on that. Let's go ahead and load up. There we go. All right, so on this site, and this is a really cool site, you can visit this anytime you like. It's National Oceanic and Atmospheric Administration. So this website is good for education purposes, as well as helping you with different assignments. You can use for science fair, you can use for different water experiments, and what have you. Okay, so hurricanes, and I'm sorry about the announcements going on right now, but we're going to continue. So hurricanes are one of nature's most powerful storms. They produce strong winds, storm surge flooding, and heavy rainfall that can lead into inland flooding, tornadoes, and rip currents. Okay. They say that hurricanes are more dangerous than tornadoes because hurricanes bring on a lot of rain, right? A lot of rain, a lot of flooding. But when you think about a hurricane and tornadoes, are some people may have the opinion that, well, a tornado is worse because look at all the damage it caused. But hurricanes cause damage too. Okay. All right. So right here, I want you to look at this picture. This right here would be your rain bands, okay? This would be your rain bands, all of these different little swirls around the hurricane. Now, right here, inside of there, inside would be what is called your eye wall, okay? But that circle in particular would be the eye, okay? That is the calmest part of the storm, okay? The calmest part of the storm. So, what is a hurricane? Hurricanes, known generically as tropical cyclones, are low pressure systems with organized thunderstorm activity that form over tropical or subtropical waters. Okay, they gain their energy from warm ocean waters. I'll say that again. They gain their energy not from spinach, but warm ocean waters. That is what fuels the hurricane. Warm water. Okay. If there is no warm water, it will begin to die out. Okay. As storm systems strengthens into hurricanes, the surface winds move continuously in a circular motion. Meteorologists refer to this pattern as closed circulation. The direction of circulation is different depending on where the storm is located. It is counterclockwise, in the northern hemisphere and clockwise in the southern hemisphere. Remember, that's that Coriolis effect. Okay, it looks like it's going different directions, but honestly, it really is. It's really kind of perpendicular. Okay, right. So right here, a storm system's strength. Oh, well, we did that part. Nope, we don't want to do that again. So look at this picture right here. It shows a hurricane moving in a counterclockwise direction. Counterclockwise direction. So if it is moving in a counterclockwise direction, is it in the northern hemisphere or southern hemisphere? I hope you said northern because I just told you that in a it is counterclockwise in the northern hemisphere. All right, make sure you're taking notes. All right, these rotating winds lead to the development of the characteristic eye of the hurricane, the calm, clear center of the storm. The eye is surrounded by the eye wall where winds are strongest. Okay, the most intense winds ever in a hurricane is in that eye wall. Okay, tropical cyclones are classified by their maximum wind speed, and you will be looking at other videos where we talk about the sapphire. What is it called? The sapphire um, model or classification model. This is what categorizes your hurricanes. Okay, this categorizes your hurricane. Okay, it's the Saffir-Simpson to be exact. All right, so this right here kind of goes over different hurricane names and what have you, and I'm not going to go over that with you all. I really, really want you to understand that the ingredients for a hurricane needs to be um, warm, moist air. It has to be over low pressure winds and warm water. Warm water, okay? So let's remember that. Remember that the northern hemisphere will always have that counterclockwise direction, but the southern hemisphere would have the clockwise direction, which talks more about that Coriolis effect from last week. So please make sure you're taking your notes. Make sure you complete your assignments for this week. I promise you, you will appreciate it. Okay? Have a great day, and I will talk to you all again later.